Okay, so this is usually a bit easier for students because, well, you have numbers and you're basically plugging numbers in. So let's just kind of dive into the formula real quick. So remember, this formula here is I find delta G, and that formula you don't have to memorize. You'll have it in the on the test, in the data booklet, on the IB exam. You won't have to memorize it. So super important formula though, because remember that if we know that the delta G is negative, or if the delta G is positive, that tells us if it's going to be spontaneous for the negative or not spontaneous for the positive. And so that's really kind of what we're after here, is um, trying to figure out what we're going to do um, with our reaction, whether we think it's going to work or whether it's just going to sit there and do nothing in the beaker. So this formula here requires certain things, and so you need a delta H, which they conveniently gave you, and you need a delta S, which they gave you data for, and you need temperature. So you have everything that you need. There's one small trick to this problem, and that's the units. And so let's go ahead and run through this and show you how you do it. So first thing you do is you're going to have to find delta S. Okay, so delta S, or the entropy, right? This is entropy, this is enthalpy, delta H is enthalpy. So delta S is simply products minus reactants. Okay, so this one has a fairly significant amount of products and reactants. So let's go ahead and do the math. So we're going to start off with 2 multiplied by chlorine's value right here. So 2 multiplied by 223. All right. Then we're going to add that to the water. So that's water, but that's water vapor. So we're looking for water as a gas. So right here. So 2 times 188.7. Okay, so there's your products. Let's subtract the reactants. So here's the hydrochloric acid. So 4 multiplied by the hydrochloric acid, which is 168, 160, 186. Sorry, 186.8 right here. Plus, now remember, you have a value for oxygen. Delta H for oxygen is going to be 0, but delta S is not 0 for elements. And so that is something that is a bit different. And then that's going to be 1, because there's only one of them, times 205.0. Okay, now, before we do the math, we need to understand one very, very important thing, that this is going to give us an answer in joules. And so remember, joules and kilojoules, not the same thing. All right. So let's run this through and let's come up with an answer. Now, the lot more going on here, so use your parentheses. So I'm going to go 2 times 223. And then we're going to add that to, in parentheses, 2 times 188.7. And then we're going to subtract, in parentheses, 4 times 186.8. And then we're going to subtract in parentheses. Well, I guess don't need the parentheses there, but 1 times 205. So, okay. So you're going to do all that. You're going to run all that through, watching your signs. Like, that's what happens. Kids get in trouble with the sign. And I would do this twice, like if I was, on the test. So the delta S is going to be negative 128.8 joules per mole. Okay, so there's your delta S. Now, what you can do now is you can come back up to our formula here, and you can see, okay, we've got all kinds of stuff there, but now we actually have 3 numbers that we can plug in. So we have 3 numbers to plug in. So let's go ahead and look at those real quick. The temperature, the delta H, and now this delta S. Now here's the problem. Delta H is in kilojoules, and delta S is in joules. Okay, so we have to get these to be the same unit. So what I would do, I always convert these joules into kilojoules. So we're going to take our delta S, and that's going to equal 128.8 joules. And then if you remember your conversion factors, if you want it to be in kilojoules, then you just divide by 1,000. And then there you go. So you're just going to basically bump the decimal point 3 spots to the left. So it's going to become 0.1288 joules. And so we're going to use this one in the formula because it matches. Sorry, I wrote down the wrong unit. If I write down the right unit, it matches the right unit. So let's go ahead and fix that. Boom. All right. Okay. So let's go ahead and now run the problem through. So let's rewrite the formula. So delta G equals delta H minus T delta S. So let's plug everything in. So it's going to equal delta H, which is right here. Okay, so that's going to be negative 114.4 kilojoules minus the temperature. Now, the temperature is right here, 298. So it's kind of up there at the top of the problem. So notice it's in Kelvin. So we're going to put 298 Kelvin. And then that's multiplied by our delta S, which we are going to use this value right here. And so that's going to be 0.1288. And so then that's also kilojoules per mole. And this is actually kilojoules per mole. All right, you can run it through and it will give us an answer. So let's just run it through and let's see what the heck we get. Okay, so negative 114.4 minus, in parentheses, 298 times 0.1288, close parentheses, hit enter, and we're going to get our answer. Okay, now checking one thing here real quick. Okay, good learning lesson. I was checking my math here real quick and I messed up my calculator. I was just sort of talking to you guys. So it's negative 114.4 minus 298 times negative, I forgot my negative there, times my negative value on my 128.8. So take a look at what I did. See this right here? Our answer was negative 128.8. And then look what I did down here. I forgot to transfer the negative sign down. And so that's the kind of thing like that, I'm talking, but I make a mistake, and then the whole problem is in jeopardy if I make that little mistake. And so that's where that bookkeeping is really important. And so that negative sign that I sort of failed to track over is really important. Okay, so let me fix that. It's not a good idea to have wrong answers in your notes. So then let's go negative 0.1288. So just that negative sign is just such a big deal because it's going to change whether or not your final answer is negative or positive a lot of times. So anyway, negative 114.4 minus, in parentheses, 298 times negative 0.1288, close parentheses, hit enter, and there we go. We get our final answer of negative 76, and let's go, looks like 4 sig figs, 3 sig figs, looks like 3 sig figs, 0.0. Right, so that's your delta G. Now, our delta G is negative. So another part of this answer would be to say that it's negative, that your delta G is negative 76 and spontaneous. So I'm going to go ahead and add that in there because I think both pieces are equally important. And spontaneous because of the negative value. All right. And so when we run through this, it's negative 76 and it's spontaneous. So that's usually what they're asking for in these questions. They want to know what the heck happens. Well, it's going to be spontaneous. Now, the size of the number, negative 76, will also determine a lot of times like how good of a job that this does. But the negative value means that this reaction is going to occur. And so that's kind of what you get out of that. So just a couple key takeaways before we pause it here. Watch the signs. I made that mistake with the signs. And then watch your units. You are always going to have to convert the joules in your S into kilojoules. And that's consistent. So, all right, I'm going to pause it here. But I want you guys to try this one on your own. Try B on your own. Same kind of problem, just it's a little easier because I gave you delta S. You don't